Hello boys and girls. Today we're going to be working on the assignment that has the heading Common Core Math 6, Unit 9, Absolute Value Distance to Area and Perimeter. Okay, this assignment has 4 basic problems, okay, where you're going to be finding the perimeter and the area of these different irregular shaped polygons. What you need to do first is take the time to graph and plot the coordinates that are given on the coordinate plane. You have room for that. And then do your very best to solve each of the problems or find the perimeter and the area of each of these shapes. If you run into problems, you can always play the video, because this video is divided into 4 segments. What I would do is I would try the first problem and then play, and then pause it when you get to the next problem, work it out on your own, then play the next segment, and so forth to check your work. If you get stuck, play the video and work along with me. Okay, let's try the first problem now.
Boys and girls, let's get out our worksheets and let's start on problem number 1. Mr. Garcia's garden is located with the following coordinates: -3, 3, 2, 3, 2, -4, -2, -4, -2, 1, and -3, 1. If each unit is 1 yard, how many yards of fencing will be needed and how many square yards of garden will need mulching? Okay, we're looking to find the perimeter of this. Well, as you can see, it's going to be a polygon. I already put I plotted the different coordinate points in place already. We're going to connect them in a moment. We're going to need to find the perimeter, and after we're done finding the perimeter, we will then find the area of this irregular shaped polygon. Let's first of all connect our points here. I'm going to do this quickly. Okay, you may want to pause the video and get caught up with this to do this on your own, because you have a blank grid in front of you that you're working on. Okay, and hopefully yours looks a little prettier than that. And then over here to right about there. And then we'll connect the last one right there. Okay, there we see we have an irregular polygon, and we're going to decompose that later when we go to find the area. But first, let's just focus on the perimeter. In order to find the perimeter, we're going to take a look at each line segment, and we're going to use the absolute value of our coordinates to figure this out. Our first one here, this is a horizontal line, so we want to focus on the x-coordinates. We take, and we can see too that our coordinates, we have a positive and a negative, so we're just going to add them. We're going to add their absolute values. So we take our first coordinate and the absolute value of negative. Oh, I got to get out of that. Let me do this real quick. Let me erase. Okay, and let me go back to pen mode. Sorry about that. Okay, so we take a look at this first line segment here. We're focusing on the x-coordinates. We want to take the absolute value of -3, okay, because we're 3 to the left of our origin. And then we want to add the absolute value of our next x-coordinate, which is 2 to the right. Okay, and all together, you're traveling 3 to the left and 2 to the right, which is a combination of, they are 5 units apart. Then let's take a look at this vertical line here. We're going to focus now on our y-coordinates. We're 3 above and 4 below. So we need to take the absolute value of our first y-coordinate, which is 3, and the absolute value of our second y-coordinate, which is -4, and add those two together, and we're going to get 7 units apart. We have another horizontal line segment here. We're going to once again take a look at our first x-coordinate, which is -2, and our other x-coordinate is 2, and the absolute value of those two is 4. Okay, we're 2 to the left, 2 to the right. Altogether, we're 4 apart. Now we have a vertical line segment here. We're focusing on our y-coordinate. Our y-coordinate there is -4. We're 4 below, but this point is 1 above. Altogether, they are 5 apart. Now this one's going to be a little different here, because both of our coordinates are going to be our x-coordinates. It's a horizontal line, but we're going from -2 to -3. So instead of adding, we're going to find their difference. And I'm going to take my larger one first, excuse me. I've got a -3 here, and I'm just going to find the difference between the absolute value of 2, which will give me 1. Okay, because what's happening here is I'm going from a -2 to the left to a -3 to the left, and those are 1 unit apart. 1 unit apart. And we're coming down the home stretch here. Our last line segment is a vertical line segment. They're both positive. So again, we're going to take the absolute value of our largest y coordinate, which is 3, and we'll find the difference between our second y coordinate, which is 1, and a +1 and a +3, they are 2 units apart. That's their difference. So all together, that's going to be our perimeter. And when we add it up, I'm going to do something. Let's see. 5 plus 5 is 10. Okay. 1 and 2 is 3. 3 plus 7 is 10. So I got 2 10s. That's 20. And a 4, that's going to be 24. And according to our units, it's going to be 24 yards. So we need 24 yards of fencing. Okay, the next part's not going to be quite as long. Excuse me. Let's decompose our regular shaped polygon. And we can see that this irregular shaped polygon is really just 2 rectangles put together. And we already know that we want to know our dimensions here. The width of this first rectangle, going from -3 to 2, is 5. Okay, and then the length of this, we're going from +3 to a +1, which makes it 2 units. So this is a 5 by 2 box, which is going to give us 10. Okay, it has the area of 10 square units, and the units are yards. Let's move on to our next rectangle. The width of this rectangle, we're going from a -2 to a +2, which when we add the absolute values of those, we're going to get 4. And the height, okay, or I should say the length of this is a -2, is a -4 to a 1. And the absolute values of those two y coordinates will be 5, the sum of those two. So 4 times 5, those are our dimensions, is 20. And all together, if we added 10 and 20 together, we'd need 30 square yards of mulching. That's the area that needs to be mulched. So we have 30 square yards of garden that needs to be mulched, and we have a perimeter of 24 yards, so that's how much fencing we'll need. Okay.
Okay, that first one wasn't that bad. Now, let's try problem number 2.
Boys and girls, let's look at problem 2. We see here Miss Brown's driveway is located within the following coordinates. I've plotted and graphed these coordinates and connected the points with the proper lines in advance to save time. It says that each unit is 1 meter, how many meters of border will be needed, and how many square meters of driveway will need asphalt. So let's start here with these 2 points, -4, 3 and -3, 3. What we're doing here is we have a horizontal line, and when we're working with horizontal lines, we're going to focus on our x coordinate, the first coordinate, which is x. And both of these coordinates are, both of the x coordinates are negative numbers. So when they're both the same, what we're going to end up doing is we're going to take the absolute value of both of them and find the difference. And when I do that, I take -4 and -3. Their absolute values is 4 and 3, and the difference is 1. See, what's really happening here is I am 4 to the left of my origin and 3 to the left of my origin, and I need to find the difference, or the space between the two, which is the difference of the two. My next point, or I should say my next line that I'm trying to find the length of, is a vertical line. Now I'm going to focus on my y-axis, the second coordinates, which would be 3 and 2. I'm going from 3 above to 2 above. And since they're both the same sign, they're both positive, I'm going to find the difference of their absolute values. Sorry. That is a 2. And that would give me a difference of 1 as well. Now I'm looking at another horizontal line, but this time my x values are a -3 and a +1. So I am 3 to the left and I am 1 to the right of my origin. That's the distance of this line here. And instead of subtracting, finding the difference, we are going to add their absolute values together. So when the signs are different, we're adding their absolute values, and that will give me a distance of 4. Now I'm going up again. Here's my next vertical line, and I'm going to focus on my y-coordinates. I'm going from a 3 to a 2. They're both positive, 3 above and 2 above. So I take the absolute value of 3 and subtract the absolute value of 2, which is 3 minus 2, and that will be 1. And then I have a horizontal line here. I'm focusing on the x-coordinates, which would be the absolute value. I'm going here from 4. I'm finding the difference from 4 to the right and 1 to the right. So the absolute value of 4 minus the absolute value of 1 will give me a difference of 3. This line here is 3. And then I have this vertical line, rather long. It's 4 above, sorry, it's 3 above and 2 below. So I take the absolute value of 3 and I add the absolute value of -2. My signs are different, so I find the sum of them, and that will give me 5. Then I have another long horizontal line which goes from 4 to -4. They have different signs, so I add. And the absolute value of 4 and the absolute value of -4 will be 8. And finally, our last line is going from 3, well actually it's, well, yeah, this vertical line here, we're looking at y. We're 3 above and 2 below. So I'm taking the absolute value of 3 and adding the absolute value of -2, which will give me a distance of 5. It's 3 above and 2 below. The distance between those two is 5. Now to get the total perimeter, I add up all of these numbers and I will get 28 meters. That's how much border I'll need to go around the driveway. Now let's find the area. Okay, what I'm going to do here is I'm going to decompose this irregular polygon into 1, 2, 3 rectangles. We see the 3 rectangles. This first rectangle, okay, we've already figured out. We know that its width is from a -3 to a -4, and the absolute difference between those two will be 1. So it's 1. So 1 by, and then we're going from 3 above to 2 below. I'm adding the absolute values of those two together, which would give me 5. So this is a 1 by 5 rectangle, which would give me the area of 5, and I'll just circle that to keep track. And then I have this rectangle here, which the width of it, I'm going from a -3 to a +1, which is 3 to the left and 1 to the right, which would give me a distance of 4. The absolute value of 3 plus the absolute value of 1 is 4. And let's check out the height of it, or the length. It is this point right here. Okay, this would be 1, 2 above and 2 below. So 2 above and 2 below, I add their absolute values together and I will get 4. So this is a 4 by 4 square, which would give me the area of 16. And then I have this rectangle out here, which the width is going from 1 to the right to 4 to the right. The difference between their absolute values would be 3. And then the height, I'm going from 3 above to 2 below. Okay, I'm sorry, my y-coordinate here is 3 above, 2 below, which would give me the absolute sum of 5, and my area would be 15. So to find my total area, I have 5 meters squared plus 16 meters squared plus 15 meters squared gives me a combined area of 36 meters squared, or square meters. So that's the amount of driveway that will need asphalt.
Well, hopefully 2 was not that difficult either, and you're becoming a real pro at this. Now let's try problem number.
Boys and girls, let's have at it again. We have number 3, and we can already tell that you can tell that this is a different type of problem. I think we're going to like it. It says, Mr. Lee is mulching around his prized miniature maple tree. The tree's coordinates are -1, 0. So right there, that's the center point, -1, 0. That's the center point of the tree. And the extent of the mulch will reach the coordinates of 2, 0, which is right there. So we're going from the center point to its fullest extent. This is also known as the radius. So if I were to draw a line connecting the center point to our circle's edge there, that would give us the radius. And I'm going to label that with the lowercase r. Let's continue. It says the mulched area will create a circular area around the tree. How many square feet will need to be mulched, and how many feet of decorative fencing will be needed to go around the mulch? So we have, once again, a perimeter problem and an area problem. But since we're dealing with a circle, our perimeter has a fancy name. It's called circumference. Okay, that's the perimeter of a circle. And we have a formula too, that C is equal to 2 pi r. And we're going to use this formula to find the circumference, which will tell us the perimeter of the circle, okay, which will give us the length needed of decorative fencing. We also have another formula for a circle, which is the area formula. And we know that the area of a circle is equal to pi r squared. I find it very interesting that both of these formulas have all the same terms, a 2, a pi, and an r, a pi, an r, and a 2. Okay, and this is a little trick I use so I don't get the 2 confused. I just remember for the circumference, C stands for circumference. It also stands for crash. The 2 crashes down to the ground. A stands for area, and the 2 floats up in the area. It's a exponent. If that helps you, keep it. If not, just memorize it. Now what I want you to do is take the radius, see if you can figure out the radius between which the radius is the distance from this point to this point here on the circle. And once you have that, see if you can find the circumference just by evaluating using this formula, and also find the area. We're going to take a little pause here, a little break. I want you to pause the video and try this on your own. Okay, let's see what you found the radius to be. Okay, now the radius would be equal. It's this horizontal line here. Now it becomes vertical over here and horizontal over here and vertical down here and diagonal every place in between. But let's look at it right here. The distance would be from -1, so we need to take the absolute value of -1, which is 1 to the left, and then also the absolute value of +2. And since we have different signs, we're going to add them. It's the distance from 1 to the left of the origin and 2 to the right of the origin gives us a combined total of 3 units. 3 units. So now we can get to work. Our r is, so we're going to plug or substitute r with 3. And while we're at it too, we're just going to approximate pi to be 3.14. So circumference is equal to 2 times 3.14 times 3. Okay, 2 times 3.14 is going to be 6 and 28 times 3. And when we multiply 6 and 28 times 3, we will get 18 and 84 feet. So that's our circumference there. That's the amount of decorative fencing that we will need to go around the circumference or the perimeter of the circle. Area, on the other hand, area is equal to 3.14 approximately times our radius, which is 3, to the second power. According to order of operations, we need to do our exponent first. 3 to the second power is 9. And then we'll multiply that by 3 and 14 which will give us 28 and 26 feet squared. And that's the area that needs to be mulched. Now you can go back and check this with your calculator to see if any of my calculations are off, but I'm pretty sure they're good. And those are your answers. I hope you found them to be your answers on your own. Let's take a look at the last problem.
Well, we're 3/4 of the way done. You're doing great. Okay, you should be a pro at this by now. But I have to warn you, problem number 4 is a challenge. You're going to have to think outside the box, maybe outside of the rectangle, triangle, circle, whatever. But I'm sure you can figure it out. You may want to get a little extra help from mom or dad, or even an older brother or sister. If you get stuck, please play the video. But you know what? I think you can do it on your own. Give it a try.
Boys and girls, we have our last problem. And this last problem is a little different than the others. In fact, I'd call it our challenge problem. But first, let's just read the problem and see where we can go from there. Number 4 says, Mr. Wilson wants a triangular-shaped dog run that will be contained within the following coordinates. And there you have the coordinates. I've already plotted them. You might want to pause so that you can plot them, as well as connect the points to create the line segments of the triangle. It says, how many square yards of lawn will need extra fertilizer, and how many yards of invisible fencing will need to be installed? Well, let's take care of the area first, and the second one is that finding the perimeter is going to be a little more challenging, and you'll see why in a moment. First of all, we know that the formula for finding the area of a triangle is base times height divided by 2, or your teacher may have said 1/2 times base times height. I prefer the base times height divided by 2, but both of these are equivalencies. They're the same thing. When we take a look at our triangle, let's find the base first. So we take a look at the bottom line segment here, and in order to find the base, we need to focus on the x-coordinates. So I have an x-coordinate of -3, and the second x-coordinate is a +1. So I find the sum of their absolute values, which would be 4. So our base is 4 units, and then our height is a vertical line segment. So we focus on the y-coordinates. Our first y-coordinate is a -4, and our second y-coordinate is a +1. They're different signs, positive and negative, so we need to find their combined absolute values, which would be 5. Okay, we're getting to be pros at this, I hope. We now take our base and height, plug it into our formula, the base, which is 4, times the height, which is 5, and divide it by 2. 4 times 5 is 20, and 20 divided by 2 is 10. So our area is going to be 10 square yards. We'll need to fertilize that square yardage. Now the next part of this problem is where I need to introduce you to some new information. Okay, it's the Pythagorean Theorem. Because see, if we try going from this point here to this point here, our line is diagonal. Okay, we can't just take an x coordinate, an x coordinate, or y and y coordinate. It's diagonal. We got a slope going on here, which is a combination of x and y. It shows a relationship that's called slope. Can't do it. Can't do it by this traditional method that we're doing so far. So what we need to do is I need to introduce what's called the Pythagorean Theorem, which simply says if you take of a right triangle, and this is a right triangle, if we take side A, which we'll call this side A, and we take side B, which is the base down here, if we take side A, the length of side A, and square it, and then add the square of side B, which is the base, if we add those two together, that's going to be equal to side C over here, which is the hypotenuse, squared. Okay, so what we need to do is we take side A, square it, add it to side B squared, and that's going to equal to C squared. So let's first substitute. Side A is going to be 5. Side B, the base, is 4, and we're going to square that, and that's going to be equal to C squared. Now, 5 times 5 is 25. No problem there. 4 times 4 is 16. Still equal to C squared. 25 plus 16 will give us 41. 41 is equal to C squared. The problem is we want to know what C is, not C squared. So what do? Well, just like we do with any other equation, except this is a new operation. Okay, we need to solve for C by performing the inverse operation. What's the inverse operation of squaring something? Well, finding the square root of it. And what we do to one side, we must do to the other. And you might want to break out a calculator for this one, since we really haven't talked much about how to find square roots yet. But we know how do I get C squared? Well, by taking C and multiplying C by it. So the square root of C squared is C. And the square root of 41, if you punch it into your calculator, it should be 6.4. Because after all, no, 6 times 6 is 36, that's too low. 7 times 7 is 49, that's too high. So it's got to be somewhere between 6 and 7. And it's approximately, if you look at your calculator, punch it in, it's going to be 6 4/10, approximately. So now we can take this C and add it to A and B. Okay, so we know that C, this side here, is going to be approximately 6.4. Let's add them up. How much of that invisible fencing we're going to need? We're going to need 5 yards plus 4 yards plus 6.4 yards, which will give us 15.5 yards of invisible fencing. Okay, I hope you enjoyed that challenge problem. You'll be using the Pythagorean Theorem later on in math. Just thought you might like to know. Okay, hope that was fun. See you later. Bye-bye.
Well, thank you for your time and effort. I hope those problems were helpful, and I hope to see you again. Let's say bye.
Bye.
Bye.